Okay, this is your lesson on ellipses 9.2. In this lesson, you will write equations of ellipses in standard form, identify the major and minor axis of an ellipse, identify the foci of an ellipse, and calculate the eccentricity of an ellipse. I'm going to go over this kind of fast because most of you already know it from Algebra 2 and also from your lesson in class. Now, if you already know this, you may want to skip over to the end of the video to view the Google form. But for those of you who want to understand this really, really well, you might want to try some of the examples in this video. A circle. We define a circle as all the points the same distance from a center point, and that gives us the radius. Okay, so if we take all the points from a center point, that will give us a circle. How we define an ellipse is if we have 2 points of reference, we tie a string to that and we draw a circle around that, or draw the figure that makes that shape with that string, we would have an ellipse. And the definition of ellipse is the same distance would be the sum of the 2 distances from each focal point or focus point to the edge of the ellipse. So these two, D1 and D2, have to add up to the same number all the way around because the string is the same length. Alright, for an ellipse, you have a major axis and a minor axis. The major axis is the longer distance across. Think of it as a diameter, the longer diameter, and the minor axis is the shorter diameter. Okay, we have a center. We have some vertices. The 2 on the major axis are called vertices, the vertex and the vertex. The ones on the minor axis are called the covertices, or covertex and covertex. Major axis, the longer one, and the minor axis is the shorter one. It could actually, the major axis could be vertical if it was longer vertically. We have 2 focus points where the nails would go if you're trying to draw that with a piece of string. Okay, those are my 2 focus points. The foci are always on the major axis. They can never be on the minor axis. Eccentricity is the flatness. The more flat it is, the larger the number, and the number is always between 0 and 1, sort of like a probability. It can never be bigger than 1, it can't be smaller than 0. It can't even be 1, because 1 would make it so flat that it would be just like a line, because it will be squished where these 2 vertices touch each other. 2 covertices will be touching each other at the center. And if it was 0, it would be so round, so not flat, it would be a circle. Okay, so we define the distance from the center to the vertex as on the horizontal axis as A, and we define the distance from the center to the vertical axis, vertical vertices, is distance B. In your textbook, they switch these back and forth depending on which one's longer. I'm always going to keep A on the x-axis and B on the y-axis. That makes our formulas a little easier. And the distance to the focus point is the distance C. And there's a relationship between A, B, and C, which is the Pythagorean theorem, except now A is actually what we used to think of as C, because that's the longer, it has to be longer than C. It would actually be the hypotenuse of this right triangle, where this be B squared plus C squared is equal to A squared. Okay, so when it's horizontal, we're going to put C over A, and when it's vertical, we're going to put C over B. So just make sure the largest number is the one that you're subtracting from. Okay, if it was vertical, then the largest number would be the distance B. If it was horizontal, the largest distance would be the distance A. All right. So if you were to graph this ellipse, this is the standard form where H and K are the center, and A is the distance on the horizontal axis from the center to the vertex, and B is from the center to the vertical on the on the axis to the vertex. So in order to graph this, we have to make sure that it's equal to 1. So if we want this to equal to 1, we have to divide it by 144. We have to divide everything by 144. When we do that, we'll get a 1 here, and then we reduce these fractions. And it would be awfully nice if we can get a 1 in front here, and we actually need a 1 in front. So if it's not a 1 in front, you're going to have a fraction in the denominator here. A little side note. Okay, which is possible. Keep that in mind if you're in honors or if you plan to take more math after this class. Okay, so here is the equation that's in standard form. We have A, we have B, we have H, and we have K. H is 0, right? If we put a 0 here, we get x minus 0 squared. That's what this is. And y minus 0 squared that's what this is. And A is 3 because 3 squared is 9. And 6 squared is 36. Now there's my center, so if I'm going to graph it, I know that my major axis is on the y-axis because it has a 6 is B is a larger number than A. So I know this is going to be vertical. So I'm going to put my A distance going 3 out this way, 3 out that way, that's A. And then B, I'm going to go 6 up and 6 down from the center, 0, 0. Then I draw that in, make that nice and smooth, like if you're driving either on your bike or on a boat. Don't make it pointy on these ends, okay? All right, that's the first example. Second example, we want to find the center, the vertices, the focus points, and the eccentricity. We want everything. In fact, and we'll give you this horrible thing here where you have to complete the square twice. So in order to make it look like this, we have a square and a square. We have to complete those squares. So let's separate our x's and our y's, and let's get rid of everything else that's not an x or a y. Leave a space here to complete the square. And then we want to factor out that 9 because we can't have anything in front when we're completing the square. It has to be a 1 coefficient in front of my y squared or x squared. What can we put in here? We can put a 4 in here. That would make a x plus 2 squared. Whatever we do one side, we have to do it the other side. Then we have to put a 9 here. This 9, we didn't actually put a 9 on this side. We actually put an 81 because we have to remember this is inside the parentheses. It gets multiplied by 9. So on this side, we get negative 49 plus 4 plus 81. Now we can write that as a square. So this will be x plus 2 squared. That gives me 4x plus 4. And y plus 3 gives me the 6 and the 9. And now we're back to where we were in the last problem. So we're going to divide everything by 36 to make it equal to 1, right? And then reduce. There's no reducing on this one, but we can reduce the 9 and the 36 to get 4. Now we know my centers at negative 2 and negative 3. Okay, that's my center. And I know that horizontal distance from the center, it would be 6, and the vertical distance would be 2. So I'm going to put those parts in. And I know my vertices are going to be h plus or minus a and k plus or minus b. And the k stays still here, and the h stays still here, right? So we have 4, or actually negative 2 plus 6, negative 2 minus 6, and then the k stays still. And then the h stays still while we take the k, which is negative 3 plus 2 and minus 2. Okay, so we have those points there. Get used to looking at, make sure you get used to looking at this. I know this is very confusing notation, but it'll help you later when the problems get more complicated. So we can draw that ellipse in there, and we found the center, check. We found the vertices, check. We need the foci. So now we have c is equal to the square root of a squared minus b squared, or you can actually grab these two numbers over here. It will be 36 minus 4, and take the square root. It will get approximately 5.7. So for the foci, since it's horizontal major axis, we're going to add those to the h. We're going to add and subtract the c from the h. So we get 3.7 -3, and -7.7, -3. So those are my focus points or foci, the two foci. Now we want the eccentricity. The eccentricity is equal to c over whichever one's longer. So it's c over 6. And we get approximately 0.89. Okay, that's one problem worked all the way through. All right. Here's another one. The completing the square is done for you, so we're just going to find the center, the vertices, the foci, and the eccentricity. You may want to pause it here, see if you can work it through, and then when you're done, take a look. Okay? Here we go. Must equal 1. It already equals 1. We're good to go. So the center is going to be at 0, 0 because it's x minus 0, y minus 0. Okay? And then I know that my a is the square root of 5, which is approximately 2.2. And then b is the square root of 20. Oh, let's finish the horizontal vertices first. So we're going to go out 2.2 in each direction from my middle, which is 0. Then b is the square root of 20, which is approximately 4.5. So we're going to go up and down from the 0 on the k. And then we get those 2 points. Okay, so those are my vertices, my co-vertices, minor axis. My major axis gives me my vertices. Okay, major axis is vertical, so we draw that in. Now my focus points, c squared is equal to b squared minus a squared because it's vertical. So then we just do that. We get approximately 3.9. So we're going to go out 3.9 in each direction from k. So we get 3.9 up, 3.9 down, where the h stands still. It's not going to go sideways, it's going to go up and down. Okay, so there we go. And the eccentricity is, let's see, it'll be c over whichever one's larger, b or a. So it's going to be 3.9 over 4.5, and that gives me about 8.7. What does this tell me? The eccentricity tells me the flatness. It's kind of good to look at a problem, look at the eccentricity, look at what the figure looks like. So this is about a 0.87. Okay, so you know that ones that are flatter will be higher than this, will be like 0.9 something, and the ones that are more circular, looking more like a circle, will be a smaller number. Okay, let's see. You may want to try this one. Pause it. When you're done, come back. All right, my center's at 1, -2. A is 4.5. B is 2. Draw my ellipse in. The center is at 1, -2. There's my C. It's horizontal, so it's a squared minus b squared. And then our vertices are going to be h plus or minus a, and then k plus or minus b. And my focus points are 5, -2, -3, -2. Eccentricity is c over whichever one of these is larger, and 4.5 is larger than 2. So we put 4 over 4.5 and get approximately 0.89. Notice the flatness looks very similar to the last one, which was 0.87. All right, if you want to do this one, okay, so just checking your work, all the same steps as before, and I hope you got that one right. Okay, what if we give you some information and we want you to come up with a standard form? You're going to write the formula. So if you know your way around, then you should be able to come up with this. Okay, so we know my major axis is 6. All right, and we know foci, my focus points are at 0, 1 and 4, 1. So if these are my focus points, I know my horizontal axis or my major axis has to go through both of these points. So my center, I have to find the center first. Center is going to be halfway between those 2 points. So we know that center is at 2, 1. If you are looking at this, you go, hey, it's going to be the average of all these numbers. So average of 0 plus 4 divided by 2 is 2. 1 plus 1 divided by 2 is 1. So that's how you find the center. Okay. So we know my major axis is 6. That means A has to equal half of that. Or, sorry, C, we're going to go this first. Okay. So that means C is the distance from the center to here, so that will be the distance between these 2 points is 4, or you can just look at the graph, hey, that's 2, right? You already know it's 2, but you know that 4 minus 0 divided by 2 is going to give you 2 anyway. So now my major axis is half of the, my A is half of the major axis, which is 6 divided by 2 is 3. And now I can find B using this formula. I have C and A. And I can square that, and then I am looking for B, and subtracting 9 from both sides, I get B is the square root of 5, or B squared. I don't really need to find the square root of 5, I just need to put B squared here, so that that's my standard form. Okay. Alright, one last one here. We'll work this all the way through. This is the last example. If you want to do it, go ahead and try it. Good practice. And I have the answers here, okay? All right. Here we go. Complete the square. Divide. And then my center, my vertices, C, my focus, my foci, and my eccentricity. So looking at this, you can tell that it's going to be pretty flat. Okay. All right. Here's your Google form. For the first 4 problems, you're going to use these multiple choices with this circle. For the next 5 problems, you're going to use these multiple choice answers for the same circle. And then you're going to give the equation of the ellipse for number 10. And for number 11, where are the foci located? Okay, I think you should be able to handle those problems. Those seem pretty easy. All right, thank you.